Let's talk a little bit about water, because as you can see, I'm under the sea. Okay, forget it. Water is a universal solvent. So what do we mean by that? Water can break down almost anything. You know those cool rocks you find in the water, they're very smooth. And you know those flatties that you can throw across and they skip? Those rocks, when they were deposited into that water, they weren't like that, but the years of water running over has smoothed them. So water can even change the shape of rocks. They can create hills and valleys. Here's a simple demonstration to show you that water is a universal solvent. This stuff here is called potassium permanganate. And all it's going to do is disperse once it gets into the water. All right, now to show you that, I'm going to pour some water in here. And I'm going to take some of this sodium permanganate. Now, if you can come down and get a straight shot in this way, or boys, ladies and gentlemen, if you can just look right here. So, and this will just show you breaking down the sodium permanganate. That's all it does. This is just an indication that water is a universal solvent. It's breaking it down as it enters, but it's so cool. I call it an upside down fireworks. Its biggest opponent is styrofoam. As you know, it takes years to break down styrofoam and it almost never changes. But remember again, water is a universal solvent. Okay, water is a sticky molecule. The way water is designed, it likes to adhere to whatever surface it's on. For example, when you get out of water, like in a shower or a bath, or if you're swimming in the ocean, the sea, a lake, swimming pool, when you get out, there is still water on you. Even though you got out of the water and it fell off, there's still water attached to you because it's a sticky molecule. It's the way it's designed. I want to do two things, but first I want to show you drops on a penny. I'll be using, they call this a pipette or a pipette. I guess it's all according to where you're from. We'll use this to make the drops. We're going to use a penny. Where's Lincoln at? There he is. But we're going to use the back where his memorial is because it's a flatter surface. We might be able to get more drops. And of course, some water. Okay guys, come join me and watch as we drop the water on the penny. Surface tension is going to hold it together. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Boys and girls, 20 drops on a penny. We could probably go further, but I really like you to look at that dome. Surface tension and water being a sticky molecule, it is holding together even though it's above the penny. This is the second experiment on water being a sticky molecule. We have here what is known as a adhesion disc, plastic, glass, and what we're going to do is put drops on there, place this down, and what we want you to do is to watch what the water does, and then we will lift that as if it was a magnet. All right, here we have the adhesion disc down, and as you can see, it's not picking up very well. Now, let's put 3 drops. Let's sort of make like a triangle drop. 1, 2, 3. Now observe what the water does when it adheres to the disc. Look how it spreads out, and it lifts. Water is a sticky molecule. Let's talk about capillary action. Once again, that's water, sticky molecule, trying to hold on to everything in its area. washable markers. And we never had washable markers back in the day, but we're going to do markers, coffee filter, plate, water. Here we go. All right, here we go. I'm going to pour some water into this plate. Take a blue marker, and I'm going to mark this coffee filter on both sides. Here I go. One side, and same thing on the other side. Capillary action is what will happen here with this paper once we place it in the water, so observe carefully. The blue can help you see the rising of the water, but that is what we call capillary action. Now what's going to stop it is gravity. It'll go up so far and then stop. And just to let you know that we're going to flip it over and do it from the other side. So watch. And what you are observing is called capillary action. And there you have it. Water can also help us, everybody, in research and learning more about how to live our lives, our daily lives. And for example, we're going to use this. This is a sodium polyacrylate. I'm going to use here a popsicle stick, a spoon, and 2 cups, one with water, one without. So here we have the sodium polyacrylate, and by the way, it was designed by NASA for the astronauts, and also you can find it in your supermarket, and we'll talk briefly about it after we get finished. But as you can see, I am going to put some in the bottom of this cup. Just a little bit more. I'm going to kind of straighten that out. And we're going to pour it in. Now, as you can see, it's not exactly water anymore. This is the stuff that they put in astronaut suits, everybody, so the astronauts can go to the bathroom, because this is a dehydrating substance and turns into a gel. When children are sick at school, this is the thing that's sprinkled on whatever came out, and so they can get it up. And what it does is each little grain can absorb, I'd say, about 2 to 250 times its size in water. And it has turned into a gel. And if I can get it out, hopefully. There's your gel. Now this is the kind of stuff you can't touch. This stuff is should be dealt with by an adult, and it's only for demonstration purposes. But you see, water can be used as a tool to help us in discovery and dealing with our everyday life. Well, I want to thank you guys for being here. And I want you to know that this is just some of the things we do here at Great Explorations in our ever-changing water exhibit.